Okay, so today we're going to talk about an important concept in algebra, independent and dependent variables. And at the end of this, we're also going to talk about scattergrams, which in some parts of the country they actually call scatter plots. So the word scattergram and scatter plot can be used synonymously. Okay, so I'm going to give you a second just to read through this. Independent variable, dependent variable, those are the two main terms that I want you to get from this page. So make sure that you read through this really well, and I'll explain it just a little bit more in just a second. Okay, make sure that you hit pause anytime you feel like maybe I didn't give a long enough pause, or you need to reread something. Just go ahead and hit pause on your video. One thing I want to talk to you about with independent and dependent is that typically whenever we talk about independent and dependent, we are talking about x's and y's. X being our independent, y being our dependent. We also call x sometimes the input, and we call y the output. And so it's important that you understand which is which. And so anytime something depends on something else, that is going to be your dependent. Independent can stand alone. Okay, for situations like this, let's go ahead and read through the first one. Let L be the loudness in decibels of the sound produced by a foghorn that is d miles away from you. So think about this. If I'm really, really close to a foghorn, then that sound is going to be very loud. If I'm really far away from the foghorn, then the sound is going to be much lighter. So the sound depends on your distance. So D would be our independent. Oops. And L for our loudness would be our dependent. Okay, and so you could also on number 1 write it like this. D, comma, L, as we would an ordered pair. Remember how in ordered pairs we put X, comma, Y? So for this we would put D, comma, L. Okay, so let's take a look at number 2. A car is traveling at a speed S in miles per hour on a dry asphalt road, and the brakes are suddenly applied. Let D be the stopping distance in feet. So, doesn't our stopping distance depend on how fast we were going? So our D depends on our S. So on number 2, I would put S, comma, D. Okay, this page is just kind of saying what I've already said. For an ordered pair AB, we write the value of the independent variable in the first or the left position and the value of the dependent variable in the second or the right position. Okay, so let's take a look at this situation. Let C be the total cost in dollars of buying W bottles of water. So we're going to buy some bottles of water, and then our cost depends on how many bottles we buy, correct? So in this case, if we were writing this as an independent-dependent ordered pair, so I would put W in my first position, which is my independent position, and I'm going to put C, my cost, in that position. So if 3 is W, 6 is C, okay? So what does 3, 6 mean in this situation? It means that if I buy 3 bottles of water, it will cost $6. That's what that means. Okay, for situations like this, I want you to take a look at, we're dealing with N being the cost of students, the cost that students spend on textbooks in millions of dollars at T years since 1995. So the question is, what does the ordered pair 3,798 mean in this situation? Well, 3 is our number of years since 1995. So part A means in 1998, students spent $798 million, because remember it says in millions of dollars, on textbooks. Okay, so look at part B. What does -2, 985 mean? -2 means I'm going to go backwards 2 years from 1995. So in 1993, students spent $985 million on textbooks. Okay, does that make sense? In 1993, students spent $985 million on textbooks. Notice that negative right there means that we had to go backwards from 1995. Okay, so whenever we collect data and we place it in a graph. That's called a scattergram or a scatter plot, which is just a collection of ordered pairs. And it helps us sketch a line that can be used to describe this situation, such as the descent of a hot air balloon. So then we can use that to make predictions and estimates about what's going on with the situation. Okay, so for this situation, a person lowers her hot air balloon by gradually releasing air from the balloon. Let A be the balloon's altitude in feet above the ground after she has released air in the balloon for T minutes. So at 0 minutes after releasing air, so keep in mind that's where we're starting. We're starting at 0 minutes. Her altitude is 2,200 feet. So after 2 minutes, she has released enough air that her altitude is now 400 feet less. At 4 minutes, she's released enough air that she's even 400 feet less than that, and so on. So next thing we're going to do is we're going to take a look at the scattergram, which is really just a bunch of points. We have a point at 0, 2,200, 2, 1,800, 4, 1,400, 6, 1,000, and 8, 600. And then we're going to draw a line that contains the points on the scattergram. Okay, so here's our dots, our ordered pairs. Remember 0, 2,200, 2, 1,800, 4, 1,400, 6, 1,000, 8, 600. And the next thing we're going to do is we're going to draw a line that goes through those points. And we're going to extend the line past where the dots are, even past that 8. So check that out. See how the line extended out here? We don't have ordered pairs that go with that, but we're going to use that line to make predictions about this situation. Okay, so read through this real quick. If the dots line up to be a line, then we say that they are linearly related. So check this out. Then what we did before is we created a model of that situation by doing the dots. The dots and the line. That's your model right there. So now what we're going to do is we're going to estimate. Use the linear model to show, or model shown, to estimate the balloon's altitude when air has been released for 5 minutes. Notice how minutes is down here on our x-axis, or our independent axis. Where is 5 on here? So it's between the 4 and the 6, right? So what I want to do is I'm going to get a ruler here, and I'm going to draw a line straight up from 5. And then what I want to do is I want to draw a line over to the left side. So now I can answer this question. Use the linear model to estimate the balloon's altitude when air has been released for 5 minutes. Well, here's the 5-minute mark right here. I went straight up, and then I look over here to the left, and I want this number right here. And it looks like that number is, let me erase just a second because it's kind of hard to tell. Looks like that number is 1,200. So it looks like the altitude is 1,200 feet. Use the linear model to predict when the balloon's altitude is 400 feet. Okay, let me erase again. I'm going to erase what we just did. And I am going to, this time, look at when the altitude is 400 feet. So the altitude is 400 feet is right here. Again, I'm using a straight edge to draw these lines. And then I'm going to look down, draw my line down, and that tells me the number of minutes. And so that's between 8 and 10. So at 9 minutes, the altitude is 400 feet. So this girl has been releasing air from this hot air balloon for 9 minutes, and she is at 400 feet.